Hey guys, what's going on? So now we're gonna continue implementing our algorithms for this linked list data structure, and now we should implement this function to add a new node at a particular position of our linked list. So let's do it. All right. So now we're gonna say void add after. That's what we called this function. It's gonna take struct node, double pointer to the head, and it's gonna take data which we're gonna add to our linked list. All right. So first of all, we should, as previously, should be able to dynamically allocate some memory on the heap for a new node. Alright. Okay, seems like we're having some issue. And after, so what's that? So it seems like I forgot my semicolon. Sorry about that, guys. Alright, so we're dynamically allocating memory on the heap for a new node because each node of our linked list is gonna live, so to speak, in a separate memory location on the heap. Alright. Struct node new node is gonna be struct node, as we've already done previously, malloc size of struct node. Alright. Next we're gonna assign some values to our newly created node. Alright. New node data is gonna be equal to data that's passed in here. Alright. And next we have some options. Alright. So first of all, we should check. So I would say we have one option. For example, what if there was a case where we did not have a head node, so that would mean that our linked list is gonna be empty, right? Is it possible? Of course it is. It is plausible, and when we start creating our linked list, it's always gonna be empty at the beginning, so, and it's normal. So let's consider that case. Okay, check if there is no previous node. So it seems like, yep. And sorry guys, I made another mistake. Here I believe that we should, we can call it previous node, and here we can change it. Here, yeah, and after, yep. So we don't need a double pointer over here, since we are not gonna change the head pointer to another memory location. All right. Because we only adding new data after this particular node, which we've called the previous node, just for the sake of simplicity. All right. So let's assume that there is no previous node. That means that there is nothing to be inserted. All right. There's no place to be inserted. There's no place to insert a newly created node. All right. So we're gonna say if no previous node. So we're gonna simply return, and that's it. next? What are we gonna do next? Next we should we created a new node, right? So how are we gonna how are we gonna add a new node to a particular position, let's say in the middle of our linked list? So let me bring this picture that which I've showed you before. So this picture. So let's pretend that this node is gonna be our new node, which we're gonna insert here in the middle between these two nodes. So let's imagine that this is the head node, the first node for instance, and this is the last node, and there is no node in between, alright? So what's our strategy? First of all, we should be able to connect our newly created node to this node, right? In order to insert this node in between, alright? So that means that the next link to our newly created node is gonna be equal to this. Is gonna point to the next node, alright? And how I'm gonna figure out what the next node is. So, and the next node is gonna be defined as data as the next pointer of the previous element, alright? So that's how we connect these two nodes. And in order to connect the previous node to the newly created node, we just simply should say that we should connect the pointer, the next pointer of the previous node to the newly created node. Yeah, and that should do it. Hopefully that makes sense. So let's write some code so that you will be able to understand it a little bit better, alright? Hopefully. So we should connect point, right, the newly created node to the next node of the previous node, like this, alright? So new node, we're gonna say new node that next, not that, so it's an arrow, of course, it's not a that, but I might confuse this two a little bit because many object-oriented programming languages use an arrow syntax and that syntax to access their data members or member functions, or if we're talking about C++ and in other languages these called properties and methods respectively. But anyway, let's get back to the track and talk about this topic of implementing algorithms in the linked lists and data structure. Alright, we should point the newly created node, the next pointer of the newly created node is gonna be equal to previous node that next. So this way we can connect this node to the next node, alright? And in order to link the previous node to our newly created node, we just gonna simply say previous next equals to new node. So, and yeah, that should do it. Alright, so guys, so guys, the next algorithm that we should implement is adding a newly created node to the end of our linked list. Alright, we're gonna say void add, so what was it called, so add end, right, add end, alright, and we're gonna pass our head double pointer to the head node, and we're gonna pass data, which is gonna be integer for this video, right, and like just like in the previous function, we're gonna say that we should allocate dynamically memory in the heap for new node, right? We're gonna say struct node, new node, and I should probably create it a separate function for a new node so that I don't repeat this code every time, but anyways, it's not about optimization, it's about implementing some algorithms, alright, and yeah, we're gonna say struct node malloc, alright, size of struct node, alright, we're gonna assign some values to our newly created node, assign values, alright, new node, data, we're gonna be data passed in here. Okay, and now we should consider the case where there is no head, and that means that, as I already pointed out before, if we don't have we don't have any elements of our linked list, that means that our linked list is empty. Okay, so and we can't add at the end. Alright, so we're gonna say if there is no head, okay, that means that our newly created node is gonna be the head node. Alright, new node, that next is gonna be equal to the head node, I suppose. Okay, and we just simply return. Alright, so next, what should we do next? Next we should be able to traverse our linked list from the beginning to the end, and yeah, that's coming about traversing linked list till the end, and point the last node of the linked list to the newly created node, right? Newly created node. Alright, so yeah, how are we gonna do that? I think that we can add a temporary variable in order to traverse our linked list. And remember, we can traverse linked lists only starting from the head, and there is no other way. We can access all the elements only one by one, starting from the head till the tail of our linked list. Alright, that's the strategy. So we're gonna say struct node temp is gonna be equal to our head to get started with. Okay, and we're gonna traverse our list till the end. We're gonna say while temp next, while it is not now. Alright, we're gonna say we're gonna traverse our linked list. Alright, we're gonna move the pointer pointer to the next element of our linked list. Alright, temp next. Okay, and finally, when we are done, when our temp next is gonna point to the null, alright, we should just point the last element, right? Last element to the newly created name. Okay. Alright guys, and that should do it, I believe, if I'm not mistaken, if I didn't mess something up, but we'll see when we are gonna, test our algorithm. Okay, and I think that we should stop here, and in the next video we're gonna continue write our functions to implement algorithms in our data structure. So I think that we can stop here, and thanks for watching, and I'll see you in the next video. Bye bye.